friends, myself Shaptaporni from BioLive. Hope all of you are doing very well. So today I am going to teach you about Lamberts Law, which is a combination of two different laws known as Law and Lamberts Law. So these two laws actually deals with the absorbance of monochromatic light through any colored solution. And that is a function, this absorption is a function of two different things, that is the concentration of the absorbing medium and the length of the absorbing medium. Okay, so now first of all we need to know why do we need this law, what is its application. If anybody gives you any unknown sample or solution, colored solution, and wants to know the concentration of that solution, then this law will be very helpful to detect or to investigate the concentration of that solution. How? You need to measure the absorbance in the form of optical density in any spectrophotometer or colorimeter, and from that you can easily detect you can easily find out the concentration of that solution. How we will know? So see, let's say this is our sample or colored solution or our absorbing medium. Okay. And L is the length of that absorbing medium. So this is the intensity of the incident light, that is I0, and this is the intensity of the transmitted light, that is I. Obviously, when any light is getting incident on your sample, its intensity will be more, because after that your sample will absorb some light energy, then it will reflect some light energy will be scattered, and after that the remaining will be seen as transmitted light. So obviously the intensity of the transmitted light will be lesser than the intensity of the incident light. That is why there is a difference in the thickness of these two intensity. Okay. Now we can write absorbance equal to I0 by I, whereas transmittance is inversely proportional to the absorbance, so that we can write it as I by I0. Why? Let's take an example. If there is a completely transparent solution, then obviously no light will be absorbed. So absorbance will be 0. As a result, all the light will get transmitted. So transmittance will be 100%. Okay, or 1. Whereas on the other hand, if you take a completely opaque sample, then all the light will get absorbed. So the absorbance will be 100% or 1. Then no light will get transmitted. So the transmittance will be 0. Okay. So we can also express absorbance in the log form. Absorbance and transmittance are inversely proportional. So A equal to, we can write it as minus log 10 base T. T equal to I by I0. So we can also write A equal to log 10 base I0 by I. Okay. Now coming to the main part, the Beer and Lamberts Law. See, the Beer's law deals with the concentration of your absorbing medium. Okay, it says that whenever any monochromatic light passes through any homogeneous colored solution, that is your absorbing medium, the amount of light absorbed is directly proportional to the concentration of the solution. That means if the concentration of the solution is more light will get absorbed. Okay, that is everything. See here, there are two test tubes, 1 and 2. The concentration of solution in test tube 1 is lesser than the second tube. So obviously the light absorbed by the first tube will be lesser than the second tube. So A1 is lesser than A2. Got it? Now coming to the Lamberts Law. Lamberts Law is a function of length of the absorbing medium or the path length travelled by the light. So it says when any monochromatic light passes through a homogeneous colored solution, the amount of light absorbed by the solution will be directly proportional to the length of the absorbing medium or the path length of your light travelled. let's say these are two cuvettes inside which our solution is present. Okay, the length of this cuvette is L1 and this cuvette is L2. L1 is lesser than L2. So obviously whenever any light will pass through this cuvette, it has to cover lesser length than this cuvette. Okay, so obviously light will be absorbed lesser in this cuvette than this cuvette. So obviously A1 will be lesser than A2. Okay, got it? So whenever we will combine these, we will get the Beer-Lamberts law. So see, what does the combination of these two laws says? Whenever a monochromatic light passes through a homogeneous colored solution, the amount of light absorbed by the colored solution is directly proportional to both the concentration and length of the absorbing medium. Okay, so absorbance will be directly proportional to the concentration of your colored solution or your absorbing medium and the length of the absorbing medium or your colored solution. Okay, so A equal to epsilon CLO, where epsilon is the molar absorbance coefficient. Okay, got it? So this is the Beer-Lamberts law, equation of Beer-Lamberts law. Now you can also write the equation from other aspects, from the aspect of intensity. Okay, you can write the I equal to I naught into e to the power minus KCl, where I is the intensity of the transmitted light, I naught is the intensity of the incident light. So obviously when the concentration and length of your absorbing medium will increase, more light will be absorbed. That means the transmitted light, the intensity of the transmitted light will be lesser. That is why we have written that intensity of the transmitted light beam decrease exponentially as the concentration and length of the absorbing medium increases. Whenever the concentration and length of the absorbing medium will increase, the absorbance will get increased. That means the transmittance will get decreased and it will decrease in an exponential manner. That is why we have given this minus sign. Okay, I equal to I naught into e to the power minus KCl, where K is a constant which depends on the wavelength of the light and the absorbing medium. Okay, so this is all about Beer-Lamberts law. I hope this is now clear to you, and we will see how we can apply this law in Lowry's test in my next video. Okay, so for the time being, thanks for watching and happy learning. Don't forget to like, share and subscribe. Thank you.